Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0A94, signifies a performance issue in the DC-DC converter of the Honda Pilot from 2016 to 2022. The DC-DC converter is crucial because it manages the conversion of high-voltage DC power from the hybrid battery to low-voltage DC power, which is used to power vehicle accessories and systems. It's part of the vehicle's electric propulsion system and is located in the engine compartment, typically near the battery. The code can trigger under specific conditions, such as load changes or electrical faults. Understanding the importance of this component and how it interacts with other systems is essential for diagnosis. The engine may not perform to its fullest potential if this component is malfunctioning, leading to various electrical issues, and may require thorough inspections and testing to uncover the exact cause. The DTC P0A94 refers specifically to a performance problem with the DC-DC converter in the Honda Pilot. The DC-DC converter plays an integral role in converting high-voltage DC power from the hybrid battery into the necessary low-voltage DC power required for vehicle components, such as lights, infotainment systems, and other electronics. This converter is located in the engine compartment, generally near the vehicle's high-voltage battery. Proper functioning of this component ensures that low-voltage systems receive adequate power for operation. As per manufacturer specifications, the connections of this converter should be checked for any signs of wear, damage, or corrosion. Any disruption in these connections may lead to performance issues and ultimately the appearance of the error code P0A94. In troubleshooting DTC P0A94, several possible causes must be evaluated. Firstly, poor connections at the DC-DC converter and the powertrain control module, PCM, can often lead to performance problems. These poor connections can create resistance that impacts the current flow. Secondly, blown fuses in the underhood fuse relay box can interrupt power supply and need to be checked. If a fuse is blown, it's critical to identify any short circuits in the wiring that may have caused it. Lastly, shorted wires in the converter signal transmission, CST line, may lead to irregular performance in the DC-DC converter, resulting in DTC P0A94. Each of these scenarios must be systematically evaluated for accurate diagnosis. Upon encountering DTC P0A94, drivers may notice several symptoms that indicate underlying issues. Engine performance problems can manifest as reduced power during acceleration, hesitation, or irregular idle conditions. The DC-DC converter's performance directly affects the vehicle's electrical components. Hence, failures in the converter could lead to system-wide electrical issues. Symptoms might include flickering lights, malfunctioning infotainment systems, or unresponsive electronic accessories. Additionally, warning lights on the dashboard may illuminate, signifying that the vehicle's systems have detected a fault and it may require immediate attention. Being aware of these signs is crucial for timely intervention to prevent further damage. The first step in troubleshooting DTC P0A94 involves confirming the code and clearing it. Begin by turning the vehicle to the on mode without starting the engine. Next, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. After clearing, perform a test drive while ensuring that the auto idle stop system operates correctly. It's important the system is tested under conditions where it would typically engage, like at a stoplight. If the auto idle stop system indicator activates and the engine continues to run, the issue requires immediate further investigation. This step is critical to ensure that the DTC is confirmed accurately at the outset. In the second troubleshooting step, you must check for any pending or confirmed DTCs using the HDS. If DTC P0A94 is indicated, it confirms a duplicated failure situation and provides a basis for further diagnosis. If P0A94 is not present, inspect the underhood fuse and relay boxes for any blown fuses. If a fuse is blown, immediate action should be taken to repair any short in the circuit. If the fuses are intact, the problem may be intermittent, suggesting that the system is currently operating normally, which invites checks for loose terminals or connectors at both the DC-DC converter and the PCM to ensure they are tight and free from corrosion. In this step, determine the possible area of failure by checking specific parameters with the HDS. Focus on monitoring the current conditions for the DC-DC converter CST, converter signal transmission line, and analyze whether they match established threshold values. If the current conditions fall within the normal parameters, continue to the next troubleshooting step. Conversely, if there are discrepancies, it indicates a potential area of failure, calling for further inspection. A proper understanding of these threshold values is vital. They serve as the baseline indicators for the health of the converter. Identifying deviations can guide the technician in addressing the core issue. This troubleshooting step involves checking for short circuits within the CST line. Begin by switching the vehicle to the off mode and jumping the SCS, service check signal, line using the HDS, then wait at least 1 minute. Following this, disconnect the DC-DC converter connector A, 3P, and PCM connector A, 51P. With these connectors disconnected, proceed to check for continuity between specific test points. Test point 1 is the number 2 terminal in the DC-DC converter connector, while test point 2 is the body ground. If continuity is present, it indicates a short in the CST line wiring between the PCM and the DC-DC converter. Step 5 focuses on verifying the ground GND line connections. Start by turning the vehicle to the off mode. Disconnect the DC-DC converter connector B, 5P, to gain access for testing. Next, measure continuity between the designated test points. Test point 1 being number 4 terminal of connector B, and test point 2 being body ground. If there's continuity, the GND line is functioning correctly. If not, it signifies an open circuit. It's crucial to understand that a faulty GND wire can lead to erratic behavior in the DC-DC converter, impacting the overall electrical system of the vehicle. Now focus on evaluating the input and output lines of the DC-DC converter. After confirming the integrity of connections, reconnect DC-DC converter connector B, 5P, and turn the vehicle to the on mode. Use the HDS to verify several parameters to identify if any input-output errors exist. This will involve checking for errors listed against the DC-DC input and output signals. Should any of the inputs indicate a malfunction, further investigation is warranted, particularly for short circuits in related wiring. By analyzing these parameters meticulously, a clearer image of the converter's health is established, enabling targeted repairs. In this step, you'll check the integrity of fuse number B14, which is located in the auxiliary underhood fuse relay box. Activate the vehicle to the off mode and examine the fuse to ascertain its condition. If the fuse is blown, it's essential to identify any short circuits in the wiring for both the DC-DC converter and the fuse. Immediately addressing any electrical shorts is critical to avoid future recurrence of DTC P0A94. Moreover, ensure that the fuse is adequately replaced to restore normal function. Simply replacing the fuse without rectifying underlying issues will not resolve the problem effectively. Step 8 entails verifying the voltage in the +B DC DC1 line to confirm whether this wire is intact. Disconnect DC-DC converter connector B, 5P, before measuring the voltage at the designated test points during the vehicle's off mode. Test point 1 is the number 1 terminal of DC-DC converter connector B, 5P, and test point 2 is the body ground. A reading of battery voltage here indicates that the +B DC-DC1 input wire is operational and functioning correctly. If battery voltage isn't detected, this signifies an open circuit in the DC-DC1 input line that needs correction. Repairing the open wire ensures the converter receives adequate power for its operations. Next, a similar process is repeated to check fuse number B13, also located in the auxiliary underhood fuse relay box. Ensure the vehicle is in off mode before assessing the fuse condition. If fuse B13 is found to be blown, investigation into any short circuits involving the +B DC-DC2 wire is warranted. This includes checking the wiring leading to the fuse and the auxiliary under-fuse relay box. Dealing with any observed wiring issues requires careful inspection to avoid future electric faults. Replacing fuse B13 without addressing shorts will likely lead to recurring problems. Maintaining the importance of systematic troubleshooting. Finally, the last troubleshooting step measures the +B DCC-DC2 line voltage to ensure the circuit's integrity. As before, start by disconnecting DC-DC converter connector B, 5P. With the vehicle in off mode, measure voltage across the designated test points. Specifically, test point 1 is the number 2 terminal of connector B, and test point 2 is the body ground. If voltage reflects battery levels, it confirms that the +B DC-DC2 connection is functional. Should the voltage be missing, it indicates an open in the wire connecting the DC-DC converter to fuse B13. Addressing such an open circuit is critical to restore the functionality of the converter. After completing all troubleshooting steps, verifying the repair's effectiveness is essential. Begin by ensuring that all electrical connections are secure and that any replaced components, such as the DC-DC converter or fuses, are correct. Use the HDS to clear any remaining DTCs and confirm any fault codes are reset. Following this, conduct a test drive to replicate the conditions that initially triggered DTC P0A94 to ensure the vehicle's performance is optimized. Pay attention to how the auto idle stop operates during this drive, confirming that the engine functions properly without throwing any new DTCs. This final verification step is crucial to ensure thorough repairs. To prevent future occurrences of DTC P0A94, consider implementing a routine preventive maintenance schedule for the electrical systems in the Honda Pilot. Regular inspections of connectors and wiring should be performed to identify signs of wear, corrosion, or physical damage. Ensure that all electrical connections are tight and free from rust or contaminants, as these can lead to increased resistance and potential issues. Additionally, routinely check the status of the fuses within the underhood fuse and relay box, replacing any that are found to be blown. Maintaining these systems proactively can significantly decrease the risk of reoccurrence of DTC P0A94. In summary, diagnosing and addressing DTC P0A94 revolves around understanding the critical role of the DC-DC converter in the Honda Pilot. Following a systematic approach to troubleshooting, starting from simple checks of vehicle settings and fuses to intricate inspections of wiring, ensures that no aspect of the diagnosis is overlooked. Each step builds upon the previous one, leading toward a thorough understanding of potential failure points and enabling targeted repairs. Ensuring that repairs are verified post-troubleshooting is fundamental to restoring vehicle functionality effectively. By proactively maintaining the electrical system, drivers can help mitigate the risk of recurring issues associated with this DTC. Please like and subscribe to the channel. See you next time!